In this video, we're going to have a look at how we can use the compound interest formula to calculate interest when maybe it's not a yearly interest rate. Maybe the interest is calculated and paid at different times. So first, let's have a talk about the different times that interest could be paid. So it might be paid on a monthly basis. So that just means at the end of every month, you'd get paid your interest. Now, it's important to remember that monthly just means there are 12 months in a year. Sometimes interest gets paid quarterly. So that just means the year is chopped up into 4 parts, 4 quarters, and the interest gets paid at the end of each of these quarters. So there are 4 quarters in a year. Sometimes interest can get paid biannually. That just means that interest gets paid 2 times. The year gets chopped in half into 2 parts. And then sometimes interest can be paid on a fortnightly basis. Now, fortnights, that just means 2 weeks. And there are 26 fortnights in a year. Now, of course, you can have your interest paid weekly as well, and there are 52 weeks in a year. So let's keep these in mind as we move forward to calculate interest that maybe gets paid on a monthly, quarterly, biannually, fortnightly, or a weekly basis. Now let's have a look at some examples. So in this first example, we're looking at 5% interest per annum, so that's a yearly interest rate, but this time it's paid monthly. So what we need to do with our formula is we just need to change the interest rate part and the compounding numbers part. So most of our formula is the same. We still have the principal, we still have 1 plus, but the rate is going to be different. Now, because this is a monthly rate that we need to work out, but we're given a yearly rate, we need to divide it by 12. So what we need to do is get our 5% interest and chop it up into 12 different parts. So in my formula, I can just write that in. You can convert it into a decimal and stick it into that spot, but if you keep it as a fraction or as a little dividing problem, you're not going to face any rounding errors. So it's best to leave it that way. Now, for our number of compounding periods, well, normally we would have it every year, but this time we're paying our interest monthly. So that just means that if we have 1 year, we need to times it by 12. So our number of compounding periods up here will be 12. So in this example, now we have 10% interest per annum, so it's a yearly interest rate. This time it's paid quarterly, and we're going to do it for 3 years. So let's find out what our rate is. Well, if we're going to pay this quarterly, that means there are 4 quarters in a year. So we need to get our interest rate and we need to chop it up, or we need to divide it into 4 parts. Now this turns nicely into 2.5, but if you get an interest rate that maybe turns into a decimal that keeps going, my tip would be leave it as a little dividing problem or a fraction. That way you'll be more accurate. Now let's have a look at the number of compounding periods. So we know that we're going to be doing this for 3 years, but instead of paying it every year, we're going to pay this quarterly, and we know that there are 4 quarters in every year. So there are going to be 12 compounding periods for this particular situation. So our formula would look like this. There we go. So let's have a look at an example where we can actually calculate the total amount that the person will have at the end. So $200,000 is invested for 5 years at 3.8% per annum, and it's paid biannually. So first, let's figure out what our interest rate needs to be. Well, we know that the annual interest rate is going to be 3.8%, but we're going to pay it biannually. And there are two periods if we're talking biannually in a year, so we need to chop our year and our interest rate into 2 equal parts. Now, I'm going to leave this one as a little dividing problem just to keep it super accurate. Now let's have a look at how many compounding periods, or the number of compounding periods that will occur over 5 years. So we know that we're going to invest this money for 5 years, and every year has 2 times that we will calculate interest. So we're going to go 5 times 2. So that just means that over the course of 5 years, there'll be 10 times that the interest will be calculated and paid back to the person. So if we use our compound interest formula, which is this one over here, let's substitute all of those values in and let's see what we get. So if we pop this one into our CAS calculator, we would end up with $241,419, and the calculator says 2.162, but I'm going to round this to 2 decimal places because we are talking about money. So this number here needs to round up. So we're going to change this to be 2.2.